seconds.
I'm Leah Coyle, and welcome to collegealgebratv.com. Calling tonight's press conference to order, welcome everyone. First of all, Mr. Malone, could you share with the crowd tonight how you have obtained the data used for this project?
Well, I just got on ESPN, went on Kevin Durant's homepage and checked out his stats.
Thank you, Mr. Malone. May you also tell the crowd tonight how you determined the function which best describes your data?
Oh yeah, I just put the X and Y values into list 1 and 2 in the calculator, and then it gave me the linear regression with the function of Y equals 0.418x plus 0.64.
And next, might you tell us how what are your intercepts for this model, Mr. Malone?
Well, the Y-intercept is 0.64, which means for every shot not taken, he makes 0.64 of those, which in a real-life situation, you can't make a shot if you don't take it.
Yeah, you know, I heard somewhere that you miss 100% of the shots that you don't take.
Oh, yeah, I've heard that
Oh,
somewhere.
yeah.
I never heard that.
Thank you kindly, Mr. Malone. I was wondering, Mr. Terry, if you might explain what the domain and range of this data set is.
For our equation, the domain and range is negative infinity to infinity, but in a real life basketball situation, you're not going to take negative shots ever, and realistically, you probably won't take more than 30 shots in a game, so the domain becomes more of a 0 to 30, and you're in that range.
And Mr. Terry, would you also elaborate on the slope?
The slope of our graph is 0.418, and what that means is basically for every shot that he takes, his percentage will go up by 0.418.
And Mr. Terry, in regards to the coefficient of determination, how well does your function model this data?
Our R-squared value for this function is 0.72, which is a pretty high number, but it's not as high as it could be. With that being said, it's a pretty decent model that we can use, but it could be better.
Mr. Terry, we certainly appreciate your responses today. Mr. Jordan, pleasure to have you here this evening.
Thank you so much for having me. The pleasure's all mine.
Now, going forward, can you make any predictions about the model and Kevin Durant's performance on the court?
Yeah, you know, if Kevin here keeps taking a high amount of shots per game, then according to the equation that we have found, he should continue to have a pretty high shooting percentage.
Thank you, Mr. Jordan. Could you also discuss the significance that this data and model holds for college and NBA recruiters?
Oh yeah. It's incredibly helpful to the recruiters and scouts these days because, you know, so many players, so many schools are getting busy, but by being able to plug these stats into the equation beforehand, you know, they kind of have a sense of who they want and who they're going to go see play, you know.
Thank you again, Mr. Jordan, and I know you're a busy man. Lastly, if you would briefly tell us, what are some of other important ways to use statistical regression to model player data?
Well, you know, it's helpful for all players out there. I'd say high school, college, even us professionals, as well as the coaches. You know, by plugging the data in, they're able to track individual and team progress, so it really helps see where the teams stand.
Thank you again, Mr. Jordan. And we wanted to thank all the fans for being here, and good night.